Hello everyone and welcome back to another lesson about Spark NLP, and today's lesson is about the general concepts of Spark NLP. Let's start together and try to study together. So first of all, one of the main concepts is Spark ML, which is a layer of Apache Spark, provides a set of machine learning applications that can be built by two different components. So one of them is called estimators and the other one is transformers. So the estimators have a method called fit, which secures and trains a piece of data to such an application. And the transformer is generally the result of the fitting process, and it applies the changes to the target datasets. So these are being implemented and embedded into Spark NLP. And also we have the concept of pipelines. Pipelines are a mechanism for combining multiple estimators and transformers into one single workflow. So this is also valid for Spark NLP. Let's try to focus what is in annotation. So annotation is the basic result of a Spark NLP operation, and it has a specific structure. So each annotation has its own annotator type. They have a begin and end, so they clearly identify the matched raw text for the content. Each of them has a result. This is the main output of the annotation. The annotation itself has a metadata structure which allows to add additional information. And as of Spark NLP 2.0, we also have embedding, so it contains vector mappings. And the object itself is automatically generated by the annotators after the transform process. So this is the main structure of annotation. And we have two types of annotators, so approaches or models. So when we refer to approach, it will mainly represent the Spark ML estimator, and it requires a training stage. And when we say models, we refer to models or transformers, meaning they have a transform data function. These are the two types of annotators mainly. And we also have some common functions, set input columns and set output columns. So these are being used when we are defining a new pipeline. And let's have a look for how we can make an annotation for a text, either via Python or Scala. These are all possible when we start the PyStack Jupyter Notebook. So you can see a sample code here. So we initialize Java version. We can enable it via Conda or Anaconda. And this is how we are making the final installation of the Spark NLP and the PySpark and initiate this Jupyter Notebook. And explain document ML, Spark NLP offers a variety of pre-trained pipelines where we are going to start soon, and how the library is working. So we can have a look to the demo application of explain document ML. When I click the demo, we are going now to the Streamlit page, and here you will be able to see what will be the result of this annotator. So this is our sample text. I can also change it, as you can see here. Let's start the first one. And first of all, we generated dependency tree out of this sample text. So you can see each tokens and the relevant part of speech and their dependencies like a tree, as you can see here. And this was the raw result. So here we see all the chunks, part of speech, the dependency and the dependency type. So this has been generated via this pipeline. And when I change the text, for example, so it's being applied to this new text as well. So you can see it here as well. Let's go back to our lecture. So we also need to be able to download and use the pre-trained pipeline. So when we call, for example, document ML annotation in a pre-trained pipeline, we need to be able to download the relevant model of the pipeline. So let's have a look to the Python source code. So first we import Spark NLP, we initiate the Spark NLP session, and then we import the pre-trained pipeline, and then we clearly define which pipeline we are going to use. So in this case, explain document ML, and this is the text that we are going to annotate. And here you can see the output. So you can see different outputs has been generated automatically. So one of them is stemming, the other one is spell check and its result, and then we have lematizer, the document itself, part of speech, tokenization, and sentence boundary. So these all have been done automatically, and also we can refer to a Spark data frame. So this is another sample code here. So these are our sentences, and here at this stage we create a Spark data frame and refer to it via this text information, and then we can call the pre-trained pipeline and we can see the output. Let's stop here. These were the main general concepts, and in the next lesson we are continue and we'll deep dive for the further concepts. Thank you for listening and have a nice day.